On the slow and successive appearance of new species. On their different rates of change. Species once lost do not reappear. Groups of species follow the same general rules in their appearance and disappearance as do single species. On extinction. On simultaneous changes in the forms of life throughout the world. On the affinities of extinct species to each other and to living species. On the state of development of ancient forms. On the succession of the same types within the same areas. Summary of preceding and present chapters. Let us now see whether the several facts and rules relating to the geological succession of organic beings better accord with the common view of the immutability of species, or with that of their slow and gradual modification, through descent and natural selection. New species have appeared very slowly, one after another, both on the land and in the waters. Lyell has shown that it is hardly possible to resist the evidence on this head in the case of the several tertiary stages, and every year tends to fill up the blanks between them, and to make the percentage system of lost and new forms more gradual. In some of the most recent beds, though undoubtedly of high antiquity if measured by years, only one or two species are lost forms, and only one or two are new forms, having here appeared for the first time, either locally, or, as far as we know, on the face of the earth. If we may trust the observations of Philippi and Sicily, the successive changes in the marine inhabitants of that island have been many and most gradual. The secondary formations are more broken, but, as Braun has remarked, neither the appearance nor disappearance of their many now extinct species has been simultaneous in each separate formation. Species of different genera and classes have not changed at the same rate, or in the same degree. In the oldest tertiary beds a few living shells may still be found in the midst of a multitude of extinct forms. Falconer has given a striking instance of a similar fact, in an existing crocodile associated with many strange and lost mammals and reptiles in the sub-Himalayan deposits. The Silurian lingula differs but little from the living species of this genus, whereas most of the other Silurian mollusks and all the crustaceans have changed greatly. The productions of the land seem to change at a quicker rate than those of the sea, of which a striking instance has lately been observed in Switzerland. There is some reason to believe that organisms, considered high in the scale of nature, change more quickly than those that are low, though there are exceptions to this rule. The amount of organic change, as Pictet has remarked, does not strictly correspond with the succession of our geological formations, so that between each two consecutive formations, the forms of life have seldom changed in exactly the same degree. Yet if we compare any but the most closely related formations, all the species will be found to have undergone some change. When a species has once disappeared from the face of the earth, we have reason to believe that the same identical form never reappears. The strongest apparent exception to this latter rule is that of the so-called colonies of Emerberand, which intrude for a period in the midst of an older formation, and then allow the pre-existing fauna to reappear, but Lyell's explanation, namely, that it is a case of temporary migration from a distinct geographical province, seems to me satisfactory. These several facts accord well with my theory. I believe in no fixed law of development, causing all the inhabitants of a country to change abruptly, or simultaneously, or to an equal degree. The process of modification must be extremely slow. The variability of each species is quite independent of that of all others. Whether such variability be taken advantage of by natural selection, and whether the variations be accumulated to a greater or lesser amount, thus causing a greater or lesser amount of modification in the varying species, depends on many complex contingencies, on the variability being of a beneficial nature, on the power of intercrossing, on the rate of breeding, on the slowly changing physical conditions of the country, and more especially on the nature of the other inhabitants with which the varying species comes into competition. Hence it is by no means surprising that one species should retain the same identical form much longer than others, or, if changing, that it should change less. We see the same fact in geographical distribution, for instance, in the land shells and coleopterous insects of Madeira having come to differ considerably from their nearest allies on the continent of Europe, whereas the marine shells and birds have remained unaltered. We can perhaps understand the apparently quicker rate of change in terrestrial and in more highly organized productions compared with marine and lower productions, by the more complex relations of the higher beings to their organic and inorganic conditions of life, as explained in a former chapter. When many of the inhabitants of a country have become modified and improved, we can understand, on the principle of competition, and on that of the many all-important relations of organism to organism, that any form which does not become in some degree modified and improved will be liable to be exterminated. Hence we can see why all the species in the same region do at last, if we look to wide enough intervals of time, become modified, for those which do not change will become extinct. In members of the same class the average amount of change, during long and equal periods of time, may, perhaps, be nearly the same, but as the accumulation of long-enduring fossiliferous formations depends on great masses of sediment having been deposited on areas whilst subsiding, our formations have been almost necessarily accumulated at wide and irregularly intermittent intervals. Consequently, the amount of organic change exhibited by the fossils embedded in consecutive formations is not equal. Each formation, on this view, does not mark a new and complete act of creation, but only an occasional scene, taken almost at hazard, in a slowly changing drama. We can clearly understand why a species when once lost should never reappear, even if the very same conditions of life, organic and inorganic, should recur. For though the offspring of one species might be adapted, and no doubt this has occurred in innumerable instances, to fill the exact place of another species in the economy of nature, and thus supplant it, yet the two forms, the old and the new, would not be identically the same, for both would almost certainly inherit different characters from their distinct progenitors. For instance, it is just possible, if our fantail pigeons were all destroyed, that fanciers, by striving during long ages for the same object, might make a new breed hardly distinguishable from our present fantail, but if the parent rock pigeon were also destroyed, and in nature we have every reason to believe that the parent form will generally be supplanted and exterminated by its improved offspring, it is quite incredible that a fantail, identical with the existing breed, could be raised from any other species of pigeon, or even from the other well-established races of the domestic pigeon, for the newly formed fantail would be almost sure to inherit from its new progenitor some slight characteristic differences. Groups of species, that is, genera and families, follow the same general rules in their appearance and disappearance as do single species, changing more or less quickly, and in a greater or lesser degree. A group does not reappear after it has once disappeared, or its existence, as long as it lasts, is continuous. I am aware that there are some apparent exceptions to this rule, but the exceptions are surprisingly few, so few, that E. Forbes, Pictet, and Woodward, though all strongly opposed to such views as I maintain, admit its truth, and the rule strictly accords with my theory. For as all the species of the same group have descended from some one species, it is clear that as long as any species of the group have appeared in the long succession of ages, so long must its members have continuously existed, in order to have generated either new and modified or the same old and unmodified forms. Species of the genus Lingula, for instance, must have continuously existed by an unbroken succession of generations, from the lowest Silurian stratum to the present day. We have seen in the last chapter that the species of a group sometimes falsely appear to have come in abruptly, and I have attempted to give an explanation of this fact, which if true would have been fatal to my views. But such cases are certainly exceptional, the general rule being a gradual increase in number, till the group reaches its maximum, and then, sooner or later, it gradually decreases. If the number of the species of a genus, or the number of the genera of a family, be represented by a vertical line of varying thickness, crossing the successive geological formations in which the species are found, the line will sometimes falsely appear to begin at its lower end, not in a sharp point, but abruptly. It then gradually thickens upwards, sometimes keeping for a space of equal thickness, and ultimately thins out in the upper beds, marking the decrease and final extinction of the species. This gradual increase in number of the species of a group is strictly conformable with my theory, as the species of the same genus, and the genera of the same family, can increase only slowly and progressively, for the process of modification and the production of a number of allied forms must be slow and gradual, one species giving rise first to 2 or 3 varieties, these being slowly converted into species, which in their turn produce by equally slow steps other species, and so on, like the branching of a great tree from a single stem, till the group becomes large. On extinction, we have as yet spoken only incidentally of the disappearance of species and of groups of species. On the theory of natural selection, the extinction of old forms and the production of new and improved forms are intimately connected together. The old notion of all the inhabitants of the earth having been swept away at successive periods by catastrophes is very generally given up, even by those geologists, as Elie de Beaumont, Murchison, Barrand, etc., whose general views would naturally lead them to this conclusion. On the contrary, we have every reason to believe, from the study of the tertiary formations, that species and groups of species gradually disappear, one after another, first from one spot, then from another, and finally from the world. Both single species and whole groups of species last for very unequal periods, some groups, as we have seen, having endured from the earliest known dawn of life to the present day, some having disappeared before the close of the Paleozoic period. No fixed law seems to determine the length of time during which any single species or any single genus endures. There is reason to believe that the complete extinction of the species of a group is generally a slower process than their production, if the appearance and disappearance of a group of species be represented, as before, by a vertical line of varying thickness. The line is found to taper more gradually at its upper end, which marks the progress of extermination, than at its lower end, which marks the first appearance and increase in numbers of the species. In some cases, however, the extermination of whole groups of beings, as of ammonites towards the close of the secondary period, has been wonderfully sudden. The whole subject of the extinction of species has been involved in the most gratuitous mystery. Some authors have even supposed that as the individual has a definite length of life, so have species a definite duration. No one, I think, can have marveled more at the extinction of species than I have done. When I found in La Plata the tooth of a horse embedded with the remains of Mastodon, Megatherium, Toxodon, and other extinct monsters, which all coexisted with still living shells at a very late geological period, I was filled with astonishment, for seeing that the horse, since its introduction by the Spaniards into South America, has run wild over the whole country and has increased in numbers at an unparalleled rate, I asked myself what could so recently have exterminated the former horse, under conditions of life apparently so favorable. But how utterly groundless was my astonishment! Professor Owen soon perceived that the tooth, though so like that of the existing horse, belonged to an extinct species. Had this horse been still living, but in some degree rare, no naturalist would have felt the least surprise at its rarity, for rarity is the attribute of a vast number of species of all classes, in all countries. If we ask ourselves why this or that species is rare, we answer that something is unfavorable in its conditions of life, but what that something is, we can hardly ever tell. On the supposition of the fossil horse still existing as a rare species, we might have felt certain from the analogy of all other mammals, even of the slow-breeding elephant, and from the history of the naturalization of the domestic horse in South America, that under more favorable conditions it would in a very few years have stocked the whole continent. But we could not have told what the unfavorable conditions were which checked its increase, whether some one or several contingencies, and at what period of the horse's life, and in what degree, they severally acted. If the conditions had gone on, however slowly, becoming less and less favorable, we assuredly should not have perceived the fact, yet the fossil horse would certainly have become rarer and rarer, and finally extinct, its place being seized on by some more successful competitor. It is most difficult always to remember that the increase of every living being is constantly being checked by unperceived injurious agencies, and that these same unperceived agencies are amply sufficient to cause rarity, and finally extinction. We see in many cases in the more recent tertiary formations, that rarity precedes extinction, and we know that this has been the progress of events with those animals which have been exterminated, either locally or wholly, through man's agency. I may repeat what I published in 1845, namely, that to admit that species generally become rare before they become extinct, to feel no surprise at the rarity of a species, and yet to marvel greatly when it ceases to exist, is much the same as to admit that sickness in the individual is the forerunner of death, to feel no surprise at sickness, but when the sick man dies, to wonder and to suspect that he died by some unknown deed of violence. The theory of natural selection is grounded on the belief that each new variety, and ultimately each new species, is produced and maintained by having some advantage over those with which it comes into competition, and the consequent extinction of less favored forms almost inevitably follows. It is the same with our domestic productions. When a new and slightly improved variety has been raised, it at first supplants the less improved varieties in the same neighborhood. When much improved, it is transported far and near, like our shorthorn cattle, and takes the place of other breeds in other countries. Thus the appearance of new forms and the disappearance of old forms, both natural and artificial, are bound together. In certain flourishing groups, the number of new specific forms which have been produced within a given time is probably greater than that of the old forms which have been exterminated, but we know that the number of species has not gone on indefinitely increasing, at least during the later geological periods, so that looking to later times we may believe that the production of new forms has caused the extinction of about the same number of old forms. The competition will generally be most severe, as formerly explained and illustrated by examples, between the forms which are most like each other in all respects. Hence the improved and modified descendants of a species will generally cause the extermination of the parent species, and if many new forms have been developed from any one species, the nearest allies of that species, i.e. the species of the same genus, will be the most liable to extermination. Thus, as I believe, a number of new species descended from one species, that is a new genus, comes to supplant an old genus, belonging to the same family. But it must often have happened that a new species belonging to some one group will have seized on the place occupied by a species belonging to a distinct group, and thus caused its extermination, and if many allied forms be developed from the successful intruder, many will have to yield their places, and it will generally be allied forms, which will suffer from some inherited inferiority in common. But whether it be species belonging to the same or to a distinct class, which yield their places to other species which have been modified and improved, a few of the sufferers may often long be preserved, from being fitted to some peculiar line of life, or from inhabiting some distant and isolated station, where they have escaped severe competition. For instance, a single species of Trigonia, a great genus of shells in the secondary formations, survives in the Australian seas, and a few members of the great and almost extinct group of ganoid fishes still inhabit our fresh waters. Therefore, the utter extinction of a group is generally, as we have seen, a slower process than its production. With respect to the apparently sudden extermination of whole families or orders, as of trilobites at the close of the Paleozoic period and of ammonites at the close of the Secondary period, we must remember what has been already said on the probable wide intervals of time between our consecutive formations, and in these intervals there may have been much slow extermination. Moreover, when by sudden immigration or by unusually rapid development, many species of a new group have taken possession of a new area, they will have exterminated in a correspondingly rapid manner many of the old inhabitants, and the forms which thus yield their places will commonly be allied, for they will partake of some inferiority in common. Thus, as it seems to me, the manner in which single species and whole groups of species become extinct accords well with the theory of natural selection. We need not marvel at extinction. If we must marvel, let it be at our presumption in imagining for a moment that we understand the many complex contingencies on which the existence of each species depends. If we forget for an instant that each species tends to increase inordinately, and that some check is always in action, yet seldom perceived by us, the whole economy of nature will be utterly obscured. Whenever we can precisely say why this species is more abundant in individuals than that, why this species and not another can be naturalized in a given country, then, and not till then, we may justly feel surprise why we cannot account for the extinction of this particular species or group of species. On the forms of life changing almost simultaneously throughout the world. Scarcely any paleontological discovery is more striking than the fact that the forms of life change almost simultaneously throughout the world. Thus, our European chalk formation can be recognized in many distant parts of the world, under the most different climates, where not a fragment of the mineral chalk itself can be found, namely, in North America, in equatorial South America, in Tierra del Fuego, at the Cape of Good Hope, and in the peninsula of India. For at these distant points, the organic remains in certain beds present an unmistakable degree of resemblance to those of the chalk. It is not that the same species are met with, for in some cases not one species is identically the same, but they belong to the same families, genera, and sections of genera, and sometimes are similarly characterized in such trifling points as mere superficial sculpture. Moreover, other forms, which are not found in the chalk of Europe, but which occur in the formations either above or below, are similarly absent at these distant points of the world. In the several successive Paleozoic formations of Russia, Western Europe, and North America, a similar parallelism in the forms of life has been observed by several authors. So it is, according to Lyell, with the several European and North American tertiary deposits. Even if the few fossil species which are common to the Old and New Worlds be kept wholly out of view, the general parallelism in the successive forms of life, in the stages of the widely separated Paleozoic and Tertiary periods, would still be manifest, and the several formations could be easily correlated. These observations, however, relate to the marine inhabitants of distant parts of the world. We have not sufficient data to judge whether the productions of the land and of fresh water change at distant points in the same parallel manner. We may doubt whether they have thus changed. If the Megatherium, Mylodon, Macrauchenia, and Toxodon had been brought to Europe from La Plata, without any information in regard to their geological position, no one would have suspected that they had coexisted with still living seashells, but as these anomalous monsters coexisted with the mastodon and horse, it might at least have been inferred that they had lived during one of the latter tertiary stages. When the marine forms of life are spoken of as having changed simultaneously throughout the world, it must not be supposed that this expression relates to the same thousandth or 100,000th year, or even that it has a very strict geological sense, for if all the marine animals which live at the present day in Europe, and all those that lived in Europe during the Pleistocene period, an enormously remote period as measured by years, including the whole glacial epoch, were to be compared with those now living in South America or in Australia, the most skillful naturalist would hardly be able to say whether the existing or the Pleistocene inhabitants of Europe resembled most closely those of the southern hemisphere. So, again, several highly competent observers believe that the existing productions of the United States are more closely related to those which lived in Europe during certain later tertiary stages, than to those which now live here, and if this be so, it is evident that fossiliferous beds deposited at the present day on the shores of North America would hereafter be liable to be classed with somewhat older European beds. Nevertheless, looking to a remotely future epoch, there can, I think, be little doubt that all the more modern marine formations, namely, the Upper Pliocene, the Pleistocene, and strictly modern beds of Europe, North and South America, and Australia, from containing fossil remains in some degree allied, and from not including those forms which are only found in the older underlying deposits, would be correctly ranked as simultaneous in a geological sense. The fact of the forms of life changing simultaneously, in the above large sense, at distant parts of the world, has greatly struck those admirable observers, MM. de Verneuil and d'Archiac. After referring to the parallelism of the Paleozoic forms of life in various parts of Europe, they add, if struck by this strange sequence, we turn our attention to North America, and there discover a series of analogous phenomena, it will appear certain that all these modifications of species, their extinction, and the introduction of new ones, cannot be owing to mere changes in marine currents or other causes more or less local and temporary, but depend on general laws which govern the whole animal kingdom. M. Barrand has made forcible remarks to precisely the same effect. It is, indeed, quite futile to look to changes of currents, climate, or other physical conditions, as the cause of these great mutations in the forms of life throughout the world, under the most different climates. We must, as Barrand has remarked, look to some special law. We shall see this more clearly when we treat of the present distribution of organic beings, and find how slight is the relation between the physical conditions of various countries and the nature of their inhabitants. This great fact of the parallel succession of the forms of life throughout the world is explicable on the theory of natural selection. New species are formed by new varieties arising, which have some advantage over older forms, and those forms, which are already dominant, or have some advantage over the other forms in their own country, would naturally oftenest give rise to new varieties or incipient species, for these latter must be victorious in a still higher degree in order to be preserved and to survive. We have distinct evidence on this head, in the plants which are dominant, that is, which are commonest in their own homes, and are most widely diffused, having produced the greatest number of new varieties. It is also natural that the dominant, varying, and far-spreading species, which already have invaded to a certain extent the territories of other species, should be those which would have the best chance of spreading still further, and of giving rise in new countries to new varieties and species. The process of diffusion may often be very slow, being dependent on climatal and geographical changes, or on strange accidents, but in the long run the dominant forms will generally succeed in spreading. The diffusion would, it is probable, be slower with the terrestrial inhabitants of distinct continents than with the marine inhabitants of the continuous sea. We might therefore expect to find, as we apparently do find, a less strict degree of parallel succession in the productions of the land than of the sea. Dominant species spreading from any region might encounter still more dominant species, and then their triumphant course, or even their existence, would cease. We know not at all precisely what are all the conditions most favorable for the multiplication of new and dominant species, but we can, I think, clearly see that a number of individuals, from giving a better chance of the appearance of favorable variations, and that severe competition with many already existing forms, would be highly favorable, as would be the power of spreading into new territories. A certain amount of isolation, recurring at long intervals of time, would probably be also favorable, as before explained. 1/4 of the world may have been most favorable for the production of new and dominant species on the land, and another for those in the waters of the sea. If two great regions had been for a long period favorably circumstanced in an equal degree, whenever their inhabitants met, the battle would be prolonged and severe, and some from one birthplace and some from the other might be victorious. But in the course of time, the forms dominant in the highest degree, wherever produced, would tend everywhere to prevail. As they prevailed, they would cause the extinction of other and inferior forms, and as these inferior forms would be allied in groups by inheritance, whole groups would tend slowly to disappear, though here and there a single member might long be enabled to survive. Thus, as it seems to me, the parallel, and, taken in a large sense, simultaneous, succession of the same forms of life throughout the world accords well with the principle of new species having been formed by dominant species spreading widely and varying, the new species thus produced being themselves dominant owing to inheritance, and to having already had some advantage over their parents or over other species, these again spreading, varying, and producing new species. The forms which are beaten and which yield their places to the new and victorious forms, will generally be allied in groups, from inheriting some inferiority in common, and therefore as new and improved groups spread throughout the world, old groups will disappear from the world, and the succession of forms in both ways will everywhere tend to correspond. There is one other remark connected with this subject worth making. I have given my reasons for believing that all our greater fossiliferous formations were deposited during periods of subsidence, and that blank intervals of vast duration occurred during the periods when the bed of the sea was either stationary or rising, and likewise when sediment was not thrown down quickly enough to embed and preserve organic remains. During these long and blank intervals I suppose that the inhabitants of each region underwent a considerable amount of modification and extinction, and that there was much migration from other parts of the world. As we have reason to believe that large areas are affected by the same movement, it is probable that strictly contemporaneous formations have often been accumulated over very wide spaces in the same quarter of the world, but we are far from having any right to conclude that this has invariably been the case, and that large areas have invariably been affected by the same movements. When two formations have been deposited in two regions during nearly but not exactly the same period, we should find in both, from the causes explained in the foregoing paragraphs, the same general succession in the forms of life, but the species would not exactly correspond, for there will have been a little more time in the one region than in the other for modification, extinction, and immigration. I suspect that cases of this nature have occurred in Europe. Mr. Prestwich, in his admirable memoirs on the Eocene deposits of England and France, is able to draw a close general parallelism between the successive stages in the two countries, but when he compares certain stages in England with those in France, although he finds in both a curious accordance in the numbers of the species belonging to the same genera, yet the species themselves differ in a manner very difficult to account for, considering the proximity of the two areas, unless, indeed, it be assumed that an isthmus separated two seas inhabited by distinct, but contemporaneous, faunas. Lyell has made similar observations on some of the later tertiary formations. Barrand, also, shows that there is a striking general parallelism in the successive Silurian deposits of Bohemia and Scandinavia. Nevertheless, he finds a surprising amount of difference in the species. If the several formations in these regions have not been deposited during the same exact periods, a formation in one region often corresponding with a blank interval in the other, and if in both regions the species have gone on slowly changing during the accumulation of the several formations and during the long intervals of time between them, in this case, the several formations in the two regions could be arranged in the same order, in accordance with the general succession of the form of life, and the order would falsely appear to be strictly parallel. Nevertheless, the species would not all be the same in the apparently corresponding stages in the two regions. On the affinities of extinct species to each other, and to living forms. Let us now look to the mutual affinities of extinct and living species. They all fall into one grand natural system, and this fact is at once explained on the principle of descent. The more ancient any form is, the more, as a general rule, it differs from living forms. But, as Buckland long ago remarked, all fossils can be classed either in still existing groups, or between them. That the extinct forms of life help to fill up the wide intervals between existing genera, families, and orders, cannot be disputed. For if we confine our attention either to the living or to the extinct alone, the series is far less perfect than if we combine both into one general system. With respect to the vertebrata, whole pages could be filled with striking illustrations from our great paleontologist, Owen, showing how extinct animals fall in between existing groups. Cuvier ranked the ruminants and pachyderms as the two most distinct orders of mammals, but Owen has discovered so many fossil links that he has had to alter the whole classification of these two orders, and has placed certain pachyderms in the same suborder with ruminants. For example, he dissolves by fine gradations the apparently wide difference between the pig and the camel. In regard to the invertebrata, Barrand, and a higher authority could not be named, asserts that he is every day taught that Paleozoic animals, though belonging to the same orders, families, or genera with those living at the present day, were not at this early epoch limited in such distinct groups as they now are. Some writers have objected to any extinct species or group of species being considered as intermediate between living species or groups. If by this term it is meant that an extinct form is directly intermediate in all its characters between two living forms, the objection is probably valid. But I apprehend that in a perfectly natural classification many fossil species would have to stand between living species, and some extinct genera between living genera, even between genera belonging to distinct families. The most common case, especially with respect to very distinct groups, such as fish and reptiles, seems to be that supposing them to be distinguished at the present day from each other by a dozen characters, the ancient members of the same two groups would be distinguished by a somewhat lesser number of characters, so that the two groups, though formerly quite distinct, at that period made some small approach to each other. It is a common belief that the more ancient a form is, by so much the more it tends to connect by some of its characters groups now widely separated from each other. This remark no doubt must be restricted to those groups which have undergone much change in the course of geological ages, and it would be difficult to prove the truth of the proposition, for every now and then even a living animal, as the lepidosiren, is discovered having affinities directed towards very distinct groups. Yet if we compare the older reptiles and batrachians, the older fish, the older cephalopods, and the Eocene mammals, with the more recent members of the same classes, we must admit that there is some truth in the remark. Let us see how far these several facts and inferences accord with the theory of descent with modification. As the subject is somewhat complex, I must request the reader to turn to the diagram in the 4th chapter. We may suppose that the numbered letters represent genera, and the dotted lines diverging from them the species in each genus. The diagram is much too simple, too few genera and too few species being given, but this is unimportant for us. The horizontal lines may represent successive geological formations, and all the forms beneath the uppermost line may be considered as extinct. The three existing genera, A14, Q14, P14, will form a small family, B14 and F14 a closely allied family or subfamily, and O14, E14, M14, a third family. These three families, together with the many extinct genera on the several lines of descent diverging from the parent form A, will form an order, for all will have inherited something in common from their ancient and common progenitor. On the principle of the continued tendency to divergence of character, which was formerly illustrated by this diagram, the more recent any form is, the more it will generally differ from its ancient progenitor. Hence we can understand the rule that the most ancient fossils differ most from existing forms. We must not, however, assume that divergence of character is a necessary contingency. It depends solely on the descendants from a species being thus enabled to seize on many and different places in the economy of nature. Therefore it is quite possible, as we have seen in the case of some Silurian forms, that a species might go on being slightly modified in relation to its slightly altered conditions of life, and yet retain throughout a vast period the same general characteristics. This is represented in the diagram by the letter F14. All the many forms, extinct and recent, descended from A, make, as before remarked, one order, and this order, from the continued effects of extinction and divergence of character, has become divided into several subfamilies and families, some of which are supposed to have perished at different periods, and some to have endured to the present day. By looking at the diagram we can see that if many of the extinct forms, supposed to be embedded in the successive formations, were discovered at several points low down in the series, the three existing families on the uppermost line would be rendered less distinct from each other. If, for instance, the genera A1, A5, A10, F8, M3, M6, M9 were disinterred, these three families would be so closely linked together that they probably would have to be united into one great family, in nearly the same manner as has occurred with ruminants and pachyderms. Yet he who objected to call the extinct genera, which thus linked the living genera of three families together, intermediate in character, would be justified, as they are intermediate, not directly, but only by a long and circuitous course through many widely different forms. If many extinct forms were to be discovered above one of the middle horizontal lines or geological formations, for instance, above number 6, but none from beneath this line, then only the two families on the left hand, namely, A14, etc., and B14, etc., would have to be united into one family, and the two other families, namely, A14 to F14 now including 5 genera, and O14 to M14, would yet remain distinct. These two families, however, would be less distinct from each other than they were before the discovery of the fossils. If, for instance, we suppose the existing genera of the two families to differ from each other by a dozen characters, in this case the genera, at the early period marked 6, would differ by a lesser number of characters, for at this early stage of descent they have not diverged in character from the common progenitor of the order, nearly so much as they subsequently diverged. Thus it comes that ancient and extinct genera are often in some slight degree intermediate in character between their modified descendants, or between their collateral relations. In nature the case will be far more complicated than is represented in the diagram, for the groups will have been more numerous, they will have endured for extremely unequal lengths of time, and will have been modified in various degrees. As we possess only the last volume of the geological record, and that in a very broken condition, we have no right to expect, except in very rare cases, to fill up wide intervals in the natural system, and thus unite distinct families or orders. All that we have a right to expect is that those groups, which have within known geological periods undergone much modification, should in the older formations make some slight approach to each other, so that the older members should differ less from each other in some of their characters than do the existing members of the same groups, and this by the concurrent evidence of our best paleontologists seems frequently to be the case. Thus, on the theory of descent with modification, the main facts with respect to the mutual affinities of the extinct forms of life to each other and to living forms seem to me explained in a satisfactory manner. And they are wholly inexplicable on any other view. On this same theory, it is evident that the fauna of any great period in the Earth's history will be intermediate in general character between that which preceded and that which succeeded it. Thus, the species which lived at the sixth great stage of descent in the diagram are the modified offspring of those which lived at the fifth stage, and are the parents of those which became still more modified at the seventh stage. Hence they could hardly fail to be nearly intermediate in character between the forms of life above and below. We must, however, allow for the entire extinction of some preceding forms, and for the coming in of quite new forms by immigration, and for a large amount of modification, during the long and blank intervals between the successive formations. Subject to these allowances, the fauna of each geological period undoubtedly is intermediate in character, between the preceding and succeeding faunas. I need give only one instance, namely, the manner in which the fossils of the Devonian system, when this system was first discovered, were at once recognized by paleontologists as intermediate in character between those of the overlying Carboniferous and underlying Silurian system. But each fauna is not necessarily exactly intermediate, as unequal intervals of time have elapsed between consecutive formations. It is no real objection to the truth of the statement that the fauna of each period as a whole is nearly intermediate in character between the preceding and succeeding faunas, that certain genera offer exceptions to the rule. For instance, mastodons and elephants, when arranged by Dr. Falconer in two series, first according to their mutual affinities and then according to their periods of existence, do not accord in arrangement. The species extreme in character are not the oldest, or the most recent, nor are those which are intermediate in character, intermediate in age. But, supposing for an instant, in this and other such cases, that the record of the first appearance and disappearance of the species was perfect, we have no reason to believe that forms successively produced necessarily endure for corresponding lengths of time. A very ancient form might occasionally last much longer than a form elsewhere subsequently produced, especially in the case of terrestrial productions inhabiting separated districts. To compare small things with great, if the principal living and extinct races of the domestic pigeon were arranged as well as they could be in serial affinity, this arrangement would not closely accord with the order and time of their production, and still less with the order of their disappearance, for the parent rock pigeon now lives, and many varieties between the rock pigeon and the carrier have become extinct, and carriers which are extreme in the important character of length of beak originated earlier than short-beaked tumblers, which are at the opposite end of the series in this same respect. Closely connected with the statement that the organic remains from an intermediate formation are in some degree intermediate in character is the fact, insisted on by all paleontologists, that fossils from two consecutive formations are far more closely related to each other than are the fossils from two remote formations. Pictet gives as a well-known instance the general resemblance of the organic remains from the several stages of the chalk formation, though the species are distinct in each stage. This fact alone, from its generality, seems to have shaken Professor Pictet in his firm belief in the immutability of species. He who is acquainted with the distribution of existing species over the globe will not attempt to account for the close resemblance of the distinct species in closely consecutive formations, by the physical conditions of the ancient areas having remained nearly the same. Let it be remembered that the forms of life, at least those inhabiting the sea, have changed almost simultaneously throughout the world, and therefore under the most different climates and conditions. Consider the prodigious vicissitudes of climate during the Pleistocene period, which includes the whole glacial period, and note how little the specific forms of the inhabitants of the sea have been affected. On the theory of descent, the full meaning of the fact of fossil remains from closely consecutive formations, though ranked as distinct species, being closely related, is obvious. As the accumulation of each formation has often been interrupted, and as long blank intervals have intervened between successive formations, we ought not to expect to find, as I attempted to show in the last chapter, in any one or two formations all the intermediate varieties between the species which appeared at the commencement and close of these periods, but we ought to find after intervals, very long as measured by years, but only moderately long as measured geologically, closely allied forms, or, as they have been called by some authors, representative species, and these we assuredly do find. We find, in short, such evidence of the slow and scarcely sensible mutation of specific forms, as we have a just right to expect to find. On the state of development of ancient forms, there has been much discussion whether recent forms are more highly developed than ancient. I will not here enter on this subject, for naturalists have not as yet defined to each other's satisfaction what is meant by high and low forms. But in one particular sense, the more recent forms must, on my theory, be higher than the more ancient, for each new species is formed by having had some advantage in the struggle for life over other and preceding forms. If under a nearly similar climate, the Eocene inhabitants of one quarter of the world were put into competition with the existing inhabitants of the same or some other quarter, the Eocene fauna or flora would certainly be beaten and exterminated, as would a secondary fauna by an Eocene, and a Paleozoic fauna by a secondary fauna. I do not doubt that this process of improvement has affected in a marked and sensible manner the organization of the more recent and victorious forms of life, in comparison with the ancient and beaten forms, but I can see no way of testing this sort of progress. Crustaceans, for instance, not the highest in their own class, may have beaten the highest mollusks. From the extraordinary manner in which European productions have recently spread over New Zealand, and have seized on places which must have been previously occupied, we may believe, if all the animals and plants of Great Britain were set free in New Zealand, that in the course of time a multitude of British forms would become thoroughly naturalized there, and would exterminate many of the natives. On the other hand, from what we see now occurring in New Zealand, and from hardly a single inhabitant of the southern hemisphere having become wild in any part of Europe, we may doubt, if all the productions of New Zealand were set free in Great Britain, whether any considerable number would be enabled to seize on places now occupied by our native plants and animals. Under this point of view, the productions of Great Britain may be said to be higher than those of New Zealand. Yet the most skillful naturalist, from an examination of the species of the two countries, could not have foreseen this result. Agassiz insists that ancient animals resemble to a certain extent the embryos of recent animals of the same classes, or that the geological succession of extinct forms is in some degree parallel to the embryological development of recent forms. I must follow Pictet and Huxley in thinking that the truth of this doctrine is very far from proved. Yet I fully expect to see it hereafter confirmed, at least in regard to subordinate groups, which have branched off from each other within comparatively recent times. For this doctrine of Agassiz accords well with the theory of natural selection. In a future chapter one shall attempt to show that the adult differs from its embryo, owing to variations supervening at a not early age, and being inherited at a corresponding age. This process, whilst it leaves the embryo almost unaltered, continually adds, in the course of successive generations, more and more difference to the adult. Thus the embryo comes to be left as a sort of picture, preserved by nature, of the ancient and less modified condition of each animal. This view may be true, and yet it may never be capable of full proof. Seeing, for instance, that the oldest known mammals, reptiles, and fish strictly belong to their own proper classes, though some of these old forms are in a slight degree less distinct from each other than are the typical members of the same groups at the present day, it would be vain to look for animals having the common embryological character of the vertebrata, until beds far beneath the lowest Silurian strata are discovered, a discovery of which the chance is very small. on the succession of the same types within the same areas. During the later tertiary periods, Mr. Clift many years ago showed that the fossil mammals from the Australian caves were closely allied to the living marsupials of that continent. In South America, a similar relationship is manifest, even to an uneducated eye, in the gigantic pieces of armor like those of the armadillo, found in several parts of La Plata, and Professor Owen has shown in the most striking manner that most of the fossil mammals, buried there in such numbers, are related to South American types. This relationship is even more clearly seen in the wonderful collection of fossil bones made by M. Lund and Clausen in the caves of Brazil. I was so much impressed with these facts that I strongly insisted, in 1839 and 1845, on this law of the succession of types, on this wonderful relationship in the same continent between the dead and the living. Professor Owen has subsequently extended the same generalization to the mammals of the Old World. We see the same law in this author's restorations of the extinct and gigantic birds of New Zealand. We see it also in the birds of the caves of Brazil. Mr. Woodward has shown that the same law holds good with seashells, but from the wide distribution of most genera of mollusks, it is not well displayed by them. Other cases could be added, as the relation between the extinct and living land shells of Madeira, and between the extinct and living brackish water shells of the Uralo-Caspian Sea. Now, what does this remarkable law of the succession of the same types within the same areas mean? He would be a bold man, who after comparing the present climate of Australia and of parts of South America under the same latitude, would attempt to account, on the one hand, by dissimilar physical conditions for the dissimilarity of the inhabitants of these two continents, and, on the other hand, by similarity of conditions, for the uniformity of the same types in each during the later tertiary periods. Nor can it be pretended that it is an immutable law that marsupials should have been chiefly or solely produced in Australia, or that edentata and other American types should have been solely produced in South America. For we know that Europe in ancient times was peopled by numerous marsupials, and I have shown in the publications above alluded to, that in America the law of distribution of terrestrial mammals was formerly different from what it now is. North America formerly partook strongly of the present character of the southern half of the continent, and the southern half was formerly more closely allied, than it is at present, to the northern half. In a similar manner we know from Falconer and Codley's discoveries, that northern India was formerly more closely related in its mammals to Africa than it is at the present time. Analogous facts could be given in relation to the distribution of marine animals. On the theory of descent with modification, the great law of the long-enduring, but not immutable, succession of the same types within the same areas is at once explained, for the inhabitants of each quarter of the world will obviously tend to leave in that quarter, during the next succeeding period of time, closely allied though in some degree modified descendants. If the inhabitants of one continent formerly differed greatly from those of another continent, so will their modified descendants still differ in nearly the same manner and degree. But after very long intervals of time and after great geographical changes, permitting much intermigration, the feebler will yield to the more dominant forms, and there will be nothing immutable in the laws of past and present distribution. It may be asked in ridicule, whether I suppose that the Megatherium and other allied huge monsters have left behind them in South America the sloth, armadillo, and anteater, as their degenerate descendants. This cannot for an instant be admitted. These huge animals have become wholly extinct, and have left no progeny. But in the caves of Brazil, there are many extinct species which are closely allied in size and in other characters to the species still living in South America, and some of these fossils may be the actual progenitors of living species. It must not be forgotten that, on my theory, all the species of the same genus have descended from some one species, so that if 6 genera, each having 8 species, be found in one geological formation, and in the next succeeding formation there be 6 other allied or representative genera with the same number of species, then we may conclude that only one species of each of the 6 older genera has left modified descendants, constituting the 6 new genera. The other 7 species of the old genera have all died out and have left no progeny. Or, which would probably be a far commoner case, 2 or 3 species of 2 or 3 alone of the 6 older genera will have been the parents of the 6 new genera, the other old species and the other whole genera having become utterly extinct. In failing orders, with the genera and species decreasing in numbers, as apparently is the case of the Edentata of South America, still fewer genera and species will have left modified blood descendants. Summary of the preceding and present chapters. I have attempted to show that the geological record is extremely imperfect, that only a small portion of the globe has been geologically explored with care, that only certain classes of organic beings have been largely preserved in a fossil state, that the number both of specimens and of species, preserved in our museums, is absolutely as nothing compared with the incalculable number of generations which must have passed away even during a single formation, that, owing to subsidence being necessary for the accumulation of fossiliferous deposits thick enough to resist future degradation, enormous intervals of time have elapsed between the successive formations, that there has probably been more extinction during the periods of subsidence, and more variation during the periods of elevation, and during the latter the record will have been least perfectly kept, that each single formation has not been continuously deposited, that the duration of each formation is, perhaps, short compared with the average duration of specific forms, that migration has played an important part in the first appearance of new forms in any one area and formation, that widely ranging species are those which have varied most, and have oftenest given rise to new species, and that varieties have at first often been local. All these causes taken conjointly must have tended to make the geological record extremely imperfect, and will to a large extent explain why we do not find interminable varieties, connecting together all the extinct and existing forms of life by the finest graduated steps. He who rejects these views on the nature of the geological record will rightly reject my whole theory. For he may ask in vain where are the numberless transitional links which must formerly have connected the closely allied or representative species, found in the several stages of the same great formation. He may disbelieve in the enormous intervals of time which have elapsed between our consecutive formations. He may overlook how important a part migration must have played, when the formations of any one great region alone, as that of Europe, are considered. He may urge the apparent, but often falsely apparent, sudden coming in of whole groups of species. He may ask where are the remains of those infinitely numerous organisms which must have existed long before the first bed of the Silurian system was deposited. I can answer this latter question only hypothetically, by saying that as far as we can see, where our oceans now extend they have for an enormous period extended, and where our oscillating continents now stand they have stood ever since the Silurian epoch, but that long before that period, the world may have presented a wholly different aspect, and that the older continents, formed of formations older than any known to us, may now all be in a metamorphosed condition, or may lie buried under the ocean. Passing from these difficulties, all the other great leading facts in paleontology seem to me simply to follow on the theory of descent with modification through natural selection. We can thus understand how it is that new species come in slowly and successively, how species of different classes do not necessarily change together, or at the same rate, or in the same degree, yet in the long run that all undergo modification to some extent. The extinction of old forms is the almost inevitable consequence of the production of new forms. We can understand why when a species has once disappeared it never reappears. Groups of species increase in numbers slowly, and endure for unequal periods of time, for the process of modification is necessarily slow, and depends on many complex contingencies. The dominant species of the larger dominant groups tend to leave many modified descendants, and thus new subgroups and groups are formed. As these are formed, the species of the less vigorous groups, from their inferiority inherited from a common progenitor, tend to become extinct together, and to leave no modified offspring on the face of the earth. But the utter extinction of a whole group of species may often be a very slow process, from the survival of a few descendants, lingering in protected and isolated situations. When a group has once wholly disappeared, it does not reappear, for the link of generation has been broken. We can understand how the spreading of the dominant forms of life, which are those that oftenest vary, will in the long run tend to people the world with allied, but modified, descendants, and these will generally succeed in taking the places of those groups of species which are their inferiors in the struggle for existence. Hence, after long intervals of time, the productions of the world will appear to have changed simultaneously. We can understand how it is that all the forms of life, ancient and recent, make together one grand system, for all are connected by generation. We can understand, from the continued tendency to divergence of character, why the more ancient a form is, the more it generally differs from those now living. Why ancient and extinct forms often tend to fill up gaps between existing forms, sometimes blending two groups previously classed as distinct into one, but more commonly only bringing them a little closer together. The more ancient a form is, the more often, apparently, it displays characters in some degree intermediate between groups now distinct, for the more ancient a form is, the more nearly it will be related to, and consequently resemble, the common progenitor of groups, since become widely divergent. Extinct forms are seldom directly intermediate between existing forms, but are intermediate only by a long and circuitous course through many extinct and very different forms. We can clearly see why the organic remains of closely consecutive formations are more closely allied to each other than are those of remote formations, for the forms are more closely linked together by generation. We can clearly see why the remains of an intermediate formation are intermediate in character. The inhabitants of each successive period in the world's history have beaten their predecessors in the race for life, and are, in so far, higher in the scale of nature, and this may account for that vague yet ill-defined sentiment, felt by many paleontologists, that organization on the whole has progressed. If it should hereafter be proved that ancient animals resemble to a certain extent the embryos of more recent animals of the same class, the fact will be intelligible. The succession of the same types of structure within the same areas during the later geological periods ceases to be mysterious, and is simply explained by inheritance. If then the geological record be as imperfect as I believe it to be, and it may at least be asserted that the record cannot be proved to be much more perfect, the main objections to the theory of natural selection are greatly diminished or disappear. On the other hand, all the chief laws of paleontology plainly proclaim, as it seems to me, that species have been produced by ordinary generation, old forms having been supplanted by new and improved forms of life, produced by the laws of variation still acting round us, and preserved by natural selection.